In this video, we're going to do a quick overview of the properties of alcohols and ethers. So if you take a look at the data table over here, if you're comparing equivalent alkanes to alcohols, you'll notice that the alcohol always seems to have a higher boiling point. So ethane to ethanol, ethanol wins. Propane to propanol, propanol wins. Hexane to hexanol, hexanol wins. And you likely know already why that is. And if you remember alcohols, they have the hydroxyl functional group, which is polar, and that allows for hydrogen bonding. And so since there's hydrogen bonding, it gives you higher boiling points and melting points compared to hydrocarbons, ethers, and other things that we didn't see yet, like ketones, aldehydes, esters, and amines. So in general, alcohols are going to have a higher boiling point than all these things that you see over here. And the hydrocarbons here include, alkanes, alkynes, and alkenes. And these names will make more sense to you later on. But just know that alcohols have pretty high boiling points compared to a lot of things because of that OH group that gives them their hydrogen bonding capabilities. But then here's something kind of interesting. So in this data table over here, you'll notice you have methanol, ethanol, propanol, butanol. They all have the same number of OHs, yet they all have different boiling points. Think about why that might be. So if the hydrogen bonding is comparable or the same between all of these, it can't be the hydrogen bonding explaining these differences in boiling point. What is different is their size. So in this situation here, larger alcohols are going to have a higher boiling point for the similar reasons that we saw earlier. Just because they're larger molecules, they have more electrons, they have more LDF, and therefore higher boiling point than smaller alcohols. And so we already know those trends. Nothing really different there. You're just kind of looking at it or reviewing it from the context of organic chemistry. So in general, if you want to also study solubility, usually alcohols are more soluble in water or polar solvents compared to hydrocarbons because of that polar hydroxyl group. However, generally, if you have larger alcohols, the larger the alcohol, even though there's OH, you're going to have a little bit less of a solubility because you have more nonpolar CH, which makes it less soluble in water. So if you look at this figure here, methanol is very soluble in water. That's what miscible means. So is ethanol, pretty soluble. And so is propanol. But then butanol becomes less soluble. So actually it's less and less soluble as your carbon chain increases. So even look at this carbon chain here. This orange number represents solubility. It's much smaller compared to all the other alcohols that we saw there. So a larger carbon chain means you're less soluble in water just because you have more nonpolar parts to you. This image here illustrates the hydrogen bonding that occurs between alcohols. So if you want to evaporate them, you need to destroy this hydrogen bond here. And this won't happen in hydrocarbons. And now we get to ethers. Ethers, they don't have the same polarity as alcohols. They don't have the OH group. There is an O group there, so it is slightly polar as a result of that, since there is it is polarized in this bond area. It's not an equal share, and it's V-shaped. So because it's slightly polar, it does have intermolecular forces that are stronger than hydrocarbons, because hydrocarbons can only do LDF, whereas this slightly polar area can do a little bit of dipole and some LDF as well, right? Because every molecule has LDF. So intermolecular forces are stronger than hydrocarbons if you have an ether. So as a result, they have higher boiling points than hydrocarbons, but they are still lower in boiling point than things like alcohols because they don't have the OH group. So they're not superpowers in terms of boiling point, but they do have it higher than hydrocarbons. Generally, ethers actually make really good solvents, and that's because they can dissolve and are soluble in both polar and non-polar solvents. So the reason for that is because they have that little polar area here, but also they have non-polar parts, quite a few non-polar parts to them as well. Usually, if you have small ones like 3 carbons or less, those are fairly soluble in water. But then as they get more and more carbon, they're going to be more insoluble in water because you have more nonpolar parts. So as I mentioned, there's no OH group, so there's no hydrogen bonding with themselves. So they have lower boiling points than alcohols. And actually most other organic classes are basically just higher than hydrocarbons, and then they're lower than everything else on that boiling point area because other functional groups have stronger intermolecular forces, and we'll learn more about that later on. In terms of reactivity, the CO bond that exists in ether is actually pretty strong. And so because it's a pretty strong bond, it's a relatively unreactive molecule. Let's go take a look at some data here. So you'll notice here we have ethane, and here we have a comparable sized um, uh, ether, methoxyethane. Notice the boiling point's a little bit higher, okay? But ethanol, comparable size, way higher there, right? That's because here you have you don't have any O or any OH, none of that's there. But here you do have the OR group, and that leads to a bit more polarity than not having that at all. And then here you have the OH group, so hydrogen bonding, and look at water. Water is way higher. It actually technically can do hydrogen bonding at 2 spots, which is why it's a lot higher with that extremely polar OH group that's there. So ethers, again, because of their CO, they are slightly polar. And so they do have higher boiling points than hydrocarbons, but that's pretty much all they're higher than. We'll see other exceptions later. And because they don't have any OH groups, well, they can't do hydrogen bonding. So again, their boiling points are lower than alcohols. That strong CO bond makes it so that they're relatively unreactive. They don't react with much. They can react, but not with much. And again, ethers are often used as solvents because they can dissolve both polar and nonpolar stuff. Since, yes, they have a slightly polar area, but they also have a lot of non-polar areas too. So you can see them dissolve a lot of non-polar things generally.